We pick up the thread of tank fabrication where we left off, attaching the old filler neck with a simple 360-degree TIG weld run inside. That's compass degrees. The metal gets a little hotter at over 1300. Peering inside against the light shows a couple of tiny pinpricks like stars in the dark for re-welding. The tank inlet flange needs a touch with the hammer to make the cap a perfect fit. While we have access, I dress the welds and take slapper and dolly to a few raised areas. Here I ponder on the magic of knowing where my hands are, even when I can't see them both. That brings me to what may be this video's only pun, though that's not a promise. Proprioception. So simple you can do it with your eyes shut. The last item inside the tank before we close up is badge fixing. One Philistine, who I shan't name, suggested using double-sided tape and glued-in screw heads. But challenge is in many ways the point of this project. Without exercise, I get noticeably less flexible year by year. The original tank used bored and threaded stubs, and we'll create something similar with raised head steel rivets. I test on scrap before attacking the tank. The rivets drilled in the lathe and tapped aligned there to complete an internal thread in the vise. My simple press tool is a socket and plug formed in the lathe. Fitted into the hole, the nut and bolt are tightened to form a raised lip on the inside and a slight recess outside to take the rivet head. A trial proves the principle. I make a simple jig to set out the rivets in pairs to the precise hole centres and angle for the badges. The tank is marked, centre popped and drilled . The press tool forms the recesses. Attach a pair of the drilled and tapped rivets and clamp the plate onto the tank, tack weld, and then remove the jig. The final stage is to run a weld around the edge, let the steel cool and test with a badge. Four straps with captive nuts will secure tank to frame. New ones, cut from 3mm plate, have nuts welded to the back and a tap run through to clean up threads. The original tank had a single fuel tap with a reserve position at the rear, while two outlets at the front took banjos and a flexible tube to allow fuel to flow from one side of the saddle to the other. This design means that to remove the tank, you must first drain it. As an aside, a common economy on lightweight motorcycles of the period was a single on-off tap with no reserve position, which still allowed a rudimentary reserve. Petrol trapped in the closed side of the saddle became the emergency supply. Our Francis Barnett plover was so equipped, and it ran dry on the way to work one morning. I operated the reserve supply, as outlined in the handbook, running the bike's front wheel up the verge and lowering the handlebars to the road. As fuel flowed across, my attention was drawn to a commotion behind me, like the jabbering of a wagon load of monkeys. I turned to see the looming side of a school bus, every window packed with excited faces. My arguably simpler plan for the Model 50 ditches the connecting tube and has a pair of taps at the rear, and I salvaged two of the threaded bosses and set them in the lathe to clean up. Another press tool will create positions for those at the rear. The one-piece base of our last session is scribed and a centre section cut out on the guillotine, allowing for a 90-degree lip to turn down and meet the saddle side. An attempt to form this in my sheet metal bender fails on so slight a lip. Only on reviewing the video do I see that setting it the other way up would have allowed me to dress the edge down with a hammer, which I do more laboriously in the vise. The process for fixing threaded bosses employs a drill, the press tool and welding once more. The old base panels have ribs pressed in for rigidity, perhaps also helpful in reducing drumming in an almost empty tank. A bead roller has the solution, with convex and concave wheels. Roll back and forth, increasing pressure with each pass. A bearing ball sitting in a centre pop and a tube with a chamfered inner form recesses to reduce the chance of fixing bolts penetrating the tank if the rubber buffers are perished or omitted. Our bead roller stand clamped in the vise and some yo-heave-ho form the top of the saddle piece. Then mark and trim the tank, front and rear. The ends of the saddle are also cut, leaving an allowance for a right angle bend which edge welds to the tank. Dress with a planishing hammer on the stake, slip into place again and mark the front. That gets the same treatment. This edge bending tool, a slotted piece of flat bar, is effective and easily made. Before we finish on the stake. With more welding in view, I grind a new sharp point on the tungsten electrode, then clamp the saddle in place and get some tack welds into the curves front and rear, before dressing the rest into shape. With both ends secured, I take a straight edge and mark a line where the saddle meets the tank's base, and then cut away the overhang with a thin disc in the angle grinder. Clean up exposed edges, ready for welding. A tap screwed in forms a handle on the first base panel. The metal workshop gets a rare visit from homecoming Angie, who once shocked this one-time welder fabricator by announcing that she didn't like the smell of metal. "You're on the telly," I tell her. Before we close up the tank, it gets a good clean with rag and cellulose thinners to remove any grease which might contaminate a weld, and it makes it ready to seal on completion to avoid a rapid return to its rusty state. So to the first base panel seam. Align lip with lip and clamp along the straight edge. A hammer handle from inside pushes outwards before tacking edge joints. These need no filler rod because the steel melts together with this joint style, found on the underside of most tanks of the period. This matchless tank is a reminder what an easy piece our Panther tank is. Panel number 2 gets the same treatment. Clamp and tack as before, repositioning until the edges align, and tack every inch or two. Then tap together between tacks and finish with longer weld runs all round. The arc needs to be within a millimetre or so of the weld seam and a couple above the weld pool, so I support the TIG torch with 2 slightly shaky hands. A woven TIG finger looks after the one closest to the action. And if you're wondering why I have a mouse mat taped to my welding screen, it's just to reduce the light which reflects off the back of the screen and obscures my view of the weld. A mime of my intended movement helps to avoid running into unseen obstacles mid-weld. Inspect for obvious gaps, tidy up edges, and sand flush the outside faces where excess weld adds no strength, only untidiness. Visual inspection is followed by a pressure test. A bung and clamp seals the filler neck, and with taps fitted, one with an air line attached, I go very easy on the pressure setting, no more than 2 or 3 pounds per square inch. If you hear the saddle's sides pop, cut the air. A pressurized tank will quickly deform beyond the point of return, blowing out the base. Soapy water and a paintbrush whisked over the seams reveals the tiniest leak. Blowing bubbles, yes, but not forever once we take the welder to the holes we find. Retest and run over once more with the sanding disc. To align fixing straps perfectly for the frame, I've knocked up this simple jig. The brackets bolt to it, and with the assembly aligned on the tank, I apply tacks to the outside edges. The MIG welder's ability to bridge gaps and the ease of adjusting heat input to favour the 1/8 inch thick straps rather than the thin sheet of the tank make it a superior choice here. The last thing we want now is to create more holes. Now remove the jig, tack the insides and fully weld all 8 seams, sanding back for a neat finish at the edges. And finally I check with the straps which will attach it to the frame, and it's job done, or very nearly. Prove the latest work with more air and soapy water. Dry off and clean up for a protective coat. This grey 2-pack etch primer, mixed 1:1 with hardener, sticks like insects to a fly screen. I've used it on aluminium and galvanised surfaces too, both notorious for rejecting paint. Brush on and leave to cure for a couple of days before you add plugs to the tap outlets and apply the last preservative, tank sealer. I don't endorse this brand above others on the market except on the basis of having used it with success on other tanks. No need for the recommended cleaning regime here because it's going onto new, thoroughly degreased steel. I put some plugs in the tank and make a little rag collar in case my steady hand deserts me. Then take a deep breath and there, not a drop spilt. With the whole tinful in the tank, rotate and twist it every which way for as long as it takes, and then some. You can't see exactly what's happening, but with a bit of imagination you won't miss anything. When every inch is covered, upturn the tank over a container to drain. And then leave open for a few days to cure, when it should look like this inside. In spring, when the days warm up again, we'll apply a skim of filler and the finishing coats. And maybe we'll even fit our new tank to a Panther.